Faraday's laws of electromagnetic induction. First law. Remember, when magnetic flux linked with coil changes, there is induced EMF in coil. Its circuit is closed. There is current in coil. There is induced EMF or current so long as there is change in magnetic flux. कहाँ से लिखा हमने ये एक्सपेरिमेंट किए थे फैराडे एंड हेनरी ने. फर्स्ट एक्सपेरिमेंट था वहां था. फ्लक्स चेंज है ईएमएफ, नो चेंज नो ईएमएफ. सेकंड लॉ, Faraday's second law of EMI. Rate change of magnetic flux is directly proportional to induced EMF. That is E d phi by dt. E and d phi by dt. N number of turns in coil. E minus n d phi by dt. This is from what? Lenz's law. So these are what Faraday's laws. Verification. Derivation. Of Faraday's laws. जो एक्सपेरिमेंट किया था फैराडे ने फिर रिपीट कर दो. क्या है? फ्लक्स चेंज करो, क्या दिखाओ? ईएमएफ, करंट. First law. Verification, derivation of first law. Change magnetic flux linked with coil. Forward motion किया, number of lines will increase, flux will increase. It was found there is current in coil. Small bulb is there that glows. This means when there is forward motion, means number of magnetic field line increases, means flux changes. ये वही है. One magnetic flux linked with coil changes, there is induced EMF, circuit is closed, there is current. Make magnet stationary. This means no change in magnetic flux. It was found that there is no current. तो क्या होगा? हिला होगा. तो first law is what? Verified, derived, proved. What this experiment suggests, that is, when magnetic flux linked with coil changes, there is induced EMF in coil. If circuit closed, there is current. ये कह रहा है ये. This one, there is induced EMF or current so long as there is change in magnetic flux. But this is first law. So first law is verified. Now verification of second law. This is that second law. If time less, more. Make motion of magnet fast. It was found current large. That is E, d phi by dt. This is second law. So Second law is verified. So this is what Faraday's laws and their derivation prove. Give direction of current in following A. Anti-clockwise. This is the answer. Anti-clockwise direction as magnetic flux linked with coil increases. ये फील्ड लाइंस हैं अब ये फर्स्ट ये फील्ड लाइंस थी अब ये नेगेटिव जैसा बिहेवियर है तो क्लॉकवाइज डायरेक्शन ऑफ करंट as magnetic flux decreases. ये कहाँ किया था जब लेंजिज ला किया तब था फ्लक्स इंक्रीज एंटी क्लॉक फ्लक्स डिक्रीज क्लॉक given figure, give direction of current. First, outside flux zero, flux increase. So current anti-clockwise direction, that is A, B, C. ये मैग्नेटिक फील्ड में है, बाहर जा रहा है, बाहर magnetic flux second case decreases, so current in what? Clockwise direction, that is C, B, A. This is cross magnetic field acting inside perpendicular to plane of board. Yeah, this is a loop. It is moving like this. This is the position of loop. Where is the loop now? This ABC loop is where? It is in same magnetic field. It is in same magnetic field. When loop changes from 1 to 2, no change of magnetic flux, so no current. Line loop changes into circular loop. This ABCD was a line loop. It changes in circular loop. Area increases. So magnetic flux increases. I is B, hence current in circular loop in anti-clockwise direction, that is A, B, C, D. This is B, cross, acting inside, dot, acting outside. Again question, line loop changes in circular loop. Area increase, but what is B? Here B was positive, here B is negative. What is the answer? Magnetic एरिया इंक्रीज हो रहा है, इंक्रीज, लेकिन ये क्या है? नेगेटिव. मैग्नेटिक फ्लक्स लिंक्ड with circular loop. What decreases? So current in clockwise direction. Give polarity of capacitor AB as shown. This is a capacitor. This is plate A. This is plate B. This is motion. Here magnetic flux increases, so current in anti-clock direction, hence A positive, B negative. A square loop of side 10 centimeter and resistance 0.7 ohm is placed in east-west plane. ये जो बोर्ड है, ये स्क्वायर लूप लगा लीजिए आप. कहाँ से रखा है? ये ईस्ट वेस्ट प्लेन में. ईस्ट, दिस इज वेस्ट, दिस इज a square loop. So this will be what? North. This will be what? South. A square loop, side 10 centimeter, resistance this, side 10 centimeter, meter square, this is area of loop. The loop is like this board. It is in east-west plane. its resistance is 0.7 ohm. A uniform magnetic field 0.1 Tesla is set up across plane northeast. Here this is B, northeast. Direction, magnetic field decreased to 0 Tesla. This means this is B1, this is what? B2. So dB, change in magnetic field, P2 minus B1, it is minus 0.1 Tesla. In 0.7 seconds, find induced EMF and current. This is the question. Again, a square loop like our board, placed east west में ये board है. Resistance is, so this is the area, this is the resistance. A uniform magnetic field is set up across plane northeast direction. ये north, ये east, ये B है. तो ये थीटा होगा, ये क्या होगा? 45 होगा, 45 degree. The magnetic field is decreased to 0. This is magnetic, the change is this. Find induced EMF. V, it is d phi by dt. ddt phi b a cos theta. A constant outside, cos theta constant outside, dB by dt. A. What is A? It is 10 ki minus 2. What is cos theta? Cos 45. What is dB? Minus 0.1. What is dt? dt is 0.7. So it is 10 minus 2. It is 1 by root 2. Minus is there. It is 1 by 7. Ten minus 2, root 2, 2, multiply by root 2, divide by root 2, 7. It is minus 1.414. 10 ki minus 2 by what? 14. Remove point with this point. Or it is 14.14. Multiplied by 10, so divide by 10. It is 1, 0, 1. 10 raised to power minus 3 volt minus E 1.01 10 की minus 3 volt. ये कहाँ से? लेंजीज ला. मैग्नीट्यूड था ये, अपोजिट कर दो. करंट E by R. E 0, 1, 10 minus 3 R 0.7. It is 1, 4 minus 3 watt ampere. A circular coil, radius 10 centimeter and of 500 turns and resistance 2 ohm is placed with its plane perpendicular to horizontal component of magnetic field. It is rotated about vertical diameter through 180 degree estimate magnitude of EMF and current horizontal component of earth field. Three 10⁻⁵ Tesla. This is a numerical. A circular coil, radius 10 centimeter, एरिया चाहिएगा हमने by of turns 500 turns. A circular coil radius 10 centimeter and 500 turns. This is the radius 10 centimeter. This is meter. Area pi r square. Turns 500 turns. Resistance 2 ohm. Placed with its plane. Here this is circular coil. This is plane of circular coil. Plane. ये plane है circular coil का. Is placed perpendicular either horizontal component other magnetic field का ये. Horizontal component of earth magnetic field इधर ये कह रहा है. Plane placed with its plane perpendicular to horizontal component of earth magnetic field. ये plane है और ये मार्कर क्या है मैग्नेटिक फील्ड का हॉरिजॉन्टल कंपोनेंट है, इसके परपेंडिकुलर रखा है ये प्लेन. और वो मैग्नेटिक फील्ड कितना है ये B1, इट इज व्हाट 3 10⁻⁵ टेस्ला. थीटा रोटेट कर दिया ये 180 डिग्री, तो B2 becomes -3 10 की -5 वाट टेस्ला। ये वर्टिकल डायामीटर है, वर्टिकल डायामीटर ये लाइन वर्टिकल डायामीटर, ये ऐसे कर दिया। तो जो यहां B था अब ये कितना हो गया 180 ये, तो dB comes out to be B2 minus B1, it is what -6 10 की -5 टेस्ला। यहाँ टाइम .25 सेकेंड्स, ये टर्न जो हुआ ये टाइम लिखा नहीं गया हमसे, तो दिस टाइम dt 25 सेकेंड। Find induced EMF E. What E? d5 by dt. dt phi here is BA cos theta. ये एरिया है, ये एरिया पर परपेंडिकुलर है मार्कर, और यही B है, यही इसी डायरेक्शन में क्या है B, तो थीटा 0, so it is only BA, तो A is outside, it is dB by dt. What is A? Pi r square, dB minus 6 dt, it comes out to be minus, solve it, .8 10 की -3 volt, so E 3.8 3 volt. Current E by R, P 3.8 10 की -3 by R, resistance was 2 ohm, so it is what 19 10 की -3 watt ampere. A conductor is in north south direction. This is a question. It falls down is EMF induced. If there is change in flux, then there will be what induced EMF. We know phi BA cos theta. Theta is angle between B and normal to area. This is that conductor, this one is that conductor. ये conductor है. ये एरिया बनाएगा, फॉल होता है जब ये दिस एरिया. तो दिस इज नॉर्मल, माई फिंगर इज नॉर्मल. ये कंडक्टर ऐसे नॉर्थ साउथ डायरेक्शन में है, ये नॉर्थ ये साउथ, ये कंडक्टर फॉल होगा. तो ये एरिया बनाया, ये दिस वन दी एरिया, ये दिस इज नॉर्मल टू एरिया. और ये क्या है? हॉरिजॉन्टल कंपोनेंट ऑफ अर्थ मैग्नेटिक फील्ड. तो हियर थीटा इज व्हाट 90. दोबारा देखिए, ये कंडक्टर फॉल हो रहा है, ये नॉर्मल है, एरिया पर नॉर्मल. ये एरिया बनाएगा कंडक्टर, ये नॉर्मल है. और ये इधर क्या है? मैग्नेटिक फील्ड, हॉरिजॉन्टल कंपोनेंट. देयरफॉर फाई बी A cos 90 B A 0. No change in magnetic flux, so no induced EMF. Question: a conductor is in east-west direction. It falls down. Is EMF induced? Why? ये कंडक्टर है, ये कहाँ है? ये ईस्ट और ये वेस्ट. ये कंडक्टर फॉल होगा तो फ्लक्स चेंज होगा, तो EMF होगी. तो वी नो फ्लक्स BA cos theta. थीटा इज एंगल बिटवीन बी एंड नॉर्मल टू एरिया. ये नॉर्मल टू एरिया है, मार्क पर नॉर्मल टू दिस एरिया. ये जब कंडक्टर फॉल होगा, जो बोर्ड है वो एरिया बनाएगा, ऐसे एरिया. तो ये नॉर्मल टू एरिया हो गया. और इधर ही क्या हो गया? वो मैग्नेटिक फील्ड का हॉरिजॉन्टल कंपोनेंट हो गया. तो हियर थीटा इज व्हाट 0. तो फाई इज BA. As conductor falls, यहां था, यहां आ गया, ये एरिया बना, और नीचे आ गया, ये एरिया बना. तो व्हाट हैपन्स? एरिया चेंजेस. सो फाई मैग्नेटिक फ्लक्स what changes, hence induced EMF. Why? Faraday's first law. So this is what about Faraday's laws of electromagnetic